Good morning, children. So welcome back to the online session of a mathematics class. So we are starting the new lesson, linear equation in two variables. So in the last class, I had given a brief introduction about linear equation in two variables and comparing the linear equation in two variables with the linear equation in one variable. Right? So in the linear equation in one variable, we will be having only one variable, that is one unknown. Okay? So whereas in the linear equation in two variables, we will be having two unknown values. So those two unknown values we should find out. So whereas in the linear equation in one variable, it will be having a unique solution. There is one and only solution. So if I am having only one variable, then definitely there will be having a unique solution, one and only solution. Whereas if it is linear equation in two variables, this may have infinitely many solutions. So we are discussing about the equations in the last class. Unfortunately, that video was interrupted. Okay, let us continue from there itself. As I told you, in a one-day cricket match, there will be two batsmen. Their partnership will be 100 runs. So what will be the individual runs? What will be the individual runs? Say suppose so the runs scored by runs scored by the batsman Raina B X. You take it as X. Runs scored by Dhoni B Y. Then we know that in a one-day cricket match, the partnership will be 100. Then we don't know the individual contribution. What is the run scored by Raina? We don't know that. What is the run scored by Dhoni? We don't know that. So but their contribution, their partnership will be 100. So the question is, what is the individual run of Raina and then Dhoni? Okay. So what is the equation? We know that contribution of run scored by Raina plus run scored by Dhoni will become 100. It means their partnership. If you want to give the partnership, you need to add both the runs, right? So you will be getting 100. This is the equation. This is the equation for the particular situation, right? So as we have discussed in the earlier from like x plus 7 is equal to 10. So this is one equation. Or otherwise, so if you want to take a situation in linear equation in one variable, say suppose assume that cost of 5 apples will be 30 rupees. What is the cost of each apple? Cost of 5 apples will be 30 rupees. What is the cost of each apple? Here there will be only one variable. What is that? Cost of each apple. Cost of one apple will be a variable. We don't know the cost of one apple. We know that the cost of 5 apples. Right. So let me take cost of one apple. I will take it as a rupees x. Then from the equation we know that cost of 5 apple, that means 5 into cost of each apple will be rupees 30. So this is the equation. So to solve this, we know that keep the x here only 30. Bring 5 to the denominator of the other side. Because if it is multiplied here, it is on the other side, it will get divided. So 5 ones are 5 6 are. So x is equal to 6. That means cost of each apple, or cost of one apple, cost of one apple is rupees 6. Right? This is one variable. This is one variable. Linear equation one variable. There will be only one variable. Okay? So here this solution or value is also a unique. This is the only value. If 5 apples cost 30 rupees, what is the cost of each apple? That will be 6 rupees only. 6 rupees only. You can't say that it is 7 rupees. You can't say it will be any other value. If I place in the equation the place of x, if I place only 6, then only I will be getting 30. So 5 x is equal to 30. So 5 x plus 6 is equal to 30. So 5 into 6, 5 into 6 are 30. Here we are getting LHS is equal to RHS. So apart from this 6, if you place any of the value in place of x, you won't get LHS is equal to RHS. Either LHS is greater than RHS or RHS is greater than LHS. Or it is smaller than LHS. So you won't get equal. Only when you place x is equal to 6, then only you will get LHS is equal to RHS. Therefore, that x is equal to 6 will become a solution. Okay, that is unique solution. This is unique solution. Whereas here, for the x and y values, I will be getting 100. For what value of x and y, I will be getting 100. For what value of x and y, I will be getting 100. Is that only unique solution as like the linear equation one variable? We'll see that. Okay. So let me take x is equal to so say suppose 7 square by right now will be 60 and 1 square by 2 will be 40. That is x is equal to 60. Then y is equal to 40. Then is equal to 100 on the RHS. 60 plus 40 is equal to 100 again. 100 is equal to 100. Therefore, x is equal to 60, y is equal to 40 is the solution because I am getting LHS is equal to RHS. LHS is equal to RHS. Clear? Okay. Here, is there only one value x is equal to 60, y is equal to 40 for that value this equation holds? You don't have any other x and y value for this equation so that LHS is equal to RHS? We'll see that. I take x is equal to 20, so y is equal to 80. And we'll observe that we substitute in this equation. What will happen? So we know that x plus y is equal to 100. So we substitute the x value 20, we substitute in the y value 80 is equal to 100. So 20 plus 80 will become 100, 100 is equal to 100. That means LHS is equal to RHS. You can observe that whereas in the linear equation one variable, I will be getting only one unique value for the LHS is equal to RHS. Okay. Apart from that value, if it is any of the values, the LHS is not equal to RHS. Whereas in linear equation on two variables, I will be getting x is equal to 60, y is equal to 40 for the LHS is equal to RHS. If I place x is equal to 20, y is equal to 80, the LHS is also RHS. If I place x is equal to 30, x is equal to 30 and y is equal to 70, then also it is 100. LHS is equal to RHS. If I place x is equal to 10 and y is equal to 90, then also it is true. That means linear equation in two variables will be having infinitely many solutions. Infinitely many solutions. I can give x is equal to 1, y is equal to 99. What is x? 1 plus 99? 100. X is equal to 2, y is equal to 98. X is equal to 3, y is equal to 97. X is equal to 4, y is equal to 96. 4 plus 96, 100. So, I will be having plenty of solutions, infinitely many solutions for the linear equation in two variables. Linear equation in two variables. Okay. So, this is about linear equation in two variables. I had told you in the last class that I am going to explain the general form of the linear equation in two variables. Okay. So, let me go to the general form of linear equation in two variables. So, what is the general form? Or standard form. General form of linear equation in two variables. Okay. What is the general form? General form is ax plus by plus c is equal to 0. Ax plus by plus c is equal to 0. Any equation, any linear equation in two variables can be written in this form. Can be written in this form, and we can obtain the value of a, b, c. Where a, b, c are the constants, x and y are the variables, as we know that. Okay. So we'll write that this is general form of a and b are not both 0 is called linear equation in two variables. So any equation in the form, any equation we can put it in the form. So any equation, so you can write this in the class work. Any equation you can put it in the, you can put in the form ax plus by plus c is equal to 0. Okay, where a, b, c are real numbers, where a, b, c are real numbers, a, b, c are real numbers, and a, b are not both 0, and a, b and A, B are not both zero, is called linear equation in two variables. Is called linear equation in two variables. Linear equation in two variables. Example. So like 2x is 3y is equal to 5. This is example of linear equation in two variables. So this is one. Second one. Root 2x otherwise root 2p plus minus 0.05 cube is equal to 5. Okay, this is also a linear equation in two variables. What are the two variables here? P and Q. You can observe that root 2 is a real number, 0.01 is also a real number, pi is also a real number. We have studied about real numbers, right? So these two are the. What is the condition for the linear equation in two variables? There must be two variables. There must be two variables. P and Q are the variables. You can observe that any equation you can put it in the form ax plus by plus c is equal to 0, where a, b, c are real numbers, a, b, c are real numbers, and a, b are not both 0. A, b are not both 0. Why they have mentioned that condition? Say suppose assume that now this is x plus y is equal to I have written that x plus y is equal to 100. That is the equation I have written that. Nothing in essence, what is that? Coefficient is 1. Nothing in essence, coefficient is 1. Okay. Now, why they have mentioned that a and b are not both 0? If a and b are anyone will become 0, what will happen? Okay. Now assume that bring this equation into general form. What is the general form? Ax plus by plus c is equal to 0. So everything should be there in the LHS. In the RHS, you should have 0. So bring this equation into that form. So 1x plus 1y, bring 100 to the LHS, it will become minus 100 is equal to 0. If I bring 1 to the LHS, there is nothing to be there in the RHS, so it is 0. So the equation you can compare with the general equation. In the place of x, we have x. So in the place of a, we have 1. So a is equal to 1. In the place of b, we have, in the place of y, we have, in the place of b, we have 1. So b is equal to 1. So in the place of c, we have constant, so minus 100. Okay. So in the place of c, we have minus 100. Okay, for this particular equation. So comparing the given equation into a general equation, so I can write the value of a, b, c. So they are given the condition that a, b are not both 0. If a or b equal to 0, what will happen? If a is equal to 0, a is equal to 0, or b is equal to 0, assume that b is equal to 0, what will happen? If b is equal to 0, then this is 0. 0 to a is what? 0. Then what is remaining? 1x plus 0 is equal to 100. So 1x is equal to 100. What is that? Is this linear equation in two variables? No, because variable y is missing. Why y is missing? Because b value is 0. So since b value is 0, 0 into everything is 0. So therefore I am getting linear equation one variable. Similarly, if a is equal to 0, then ax is equal to 0, then this term becomes 0, this y is equal to 100. That means that is not linear equation in two variables, that is linear equation in one variable. Therefore, if it is linear equation in two variables, there should be a and b are not both 0. A and b are not both 0. If a and b are not both 0, okay. If both are 0, then that will be, there is no equation. There is no equation. So a and b are not both 0. Right? So this is general equation, and comparing the general equation to obtain the coefficients. Right? Okay. They have given that, write each of the following equations in the form of Write each of the following. Write each of the following. Write each of the following equations in the form. Equations in the form ax plus dy plus c is equal to 0. Equal to 0. And indicate the values of a, b, and c. And indicate the values of indicates the value of a, b, and c. Okay. So we need to write the given equation in the form of general equation, and then we should find out the a, b, c constants. Real numbers we should find out what are the real numbers. Okay. So the first question is 2x plus 3y. 2x plus 3y is equal to 2x plus 3y can be written as 4.37. Okay. So in this equation we should write what is value of a, what is value of b, and what is the value of c. We should write in the form of ax plus dy plus c. In that form we should write. So this equation, so 2x plus 3y. So in order to write in general form, RHS we should have a 0, so that whatever the value there in the RHS, bring into the RHS, bring into the LHS. Okay, I'm having the RHS 4.37, bring into LHS will become minus 4.37, correct? Is equal to 0. Now it is in exactly in the form of ax plus by plus c is equal to 0. Ax 2x, dy 3y, c minus 4.37. Okay. Now comparing with ax plus dy plus c is equal to 0, we get, so x, the place of a we have 2. Okay. Y, in the place of b 3. So plus minus. So in the place of c minus 4.37. So c is equal to minus 4.37. This is representing the equation in general form and writing the a value, b value, c value. Right? So whenever they are given the equation, any equations, we need to check whether the given equation, whether in the form of a linear equation in two variables or not. If you want to check that equation in the form of linear equation in two variables or not, we should remember the general form of the linear equation in two variables. This is the general form. Then we should find out that whether a, b, c are the real numbers. A, b, c are the real numbers. Because the condition for the general equation in two variables or linear equation in two variables is that it should be in the form of ax plus by plus c is equal to 0, where a, b, c are the real numbers. A, b, c are the real numbers. Okay. So this is about writing the given equation in terms of the general form and taking the values of a, b, c. Okay. So I will give you some homework regarding this. You have to find out. The second equation is x minus 4 is equal to root 3y. So this is the second equation. Third equation is 4 is equal to 5x minus 3y. Whenever we are adding minus, you should be very careful that you should write the sign also. Okay? Because the general form we are adding plus, everywhere plus. Okay? Plus. So whenever there is a minus in the equation, given equation, you should take that minus also, right? So fourth equation is 2x is equal to y. So this is the homework for you. You have to write, you have to complete these homeworks. Okay. So in the next class, again, we will go for exercise 4.1. There we have some situation. The situation should convert into a linear equation with two variables. And again, we have same type of question of the day. We'll solve that. Then we will go for how to find out the solution of the linear equations. Okay. That's it for today's class. Any doubts, please feel free to contact me. Thank you. We will meet in the